Okay, guys, we're going to go back a few lessons. I'm going to ask you to recall something. I've got a sequence of numbers up here on the board, and this sequence has a name. It's a certain kind of sequence. Do you remember what it was, Jackson?
Arithmetic.
Arithmetic. How do you know it's arithmetic?
Because it's increasing by the same amount.
Aha, it's increasing by the same amount. To get from here to here, you add 2. To get from here to here, you add 2, add 2, add 2. So obviously the next term here would be 9. But I want to ask a harder question. What is the 200th term in this sequence? Now, this was the first term, and this was the second term, and this was the third term, and this was the fourth term. But we're going to need to figure out a formula for the nth term. So how do we go about doing this? If we were to graph these numbers, first term, second term, third term, fourth term, fifth term, the first term was -3, the second term was -1, the third term was +1, and then +3, and then +5, we would have a nice linear function. Man, we've spent a lot of time talking about linear functions. If you need to, think of the equation of this line. Becca?
We're multiplying by 2 and subtracting 5.
Okay. First, she said, since we're growing by 2 each time, that means every time you go 1 to the right, you're going 2 up, so the slope of the line is 2. So that's why she put a 2 out in front of the variable. If this were the equation of this line, we would say y equals 2x, right? But then we have a y-intercept. So what did you say the other number was?
You subtract 5.
Subtract 5. Evidently, the equation of this line is y equals 2x minus 5. Now, we can check that out. Let's put 2 into our formula. 2 times 2 is 4, minus 5, -1. Let's put 3 into our formula. 2 times 3 is 6, minus 5, +1. So you're right. Let's see, this is 1, 2, 3, 4, 5, 6. This is the 7th term. 2 times 7 is 14, minus 5 is 9. The 7th term is 9. So she's got the correct formula up there. Now I can't remember what I asked you. What is the 100th term? So, Becca, what is the 100th term?
Be 195.
Yeah, because it's 2 times 100 minus 5. So, the point of that whole exercise was that arithmetic sequences are just like linear functions because they are growing by the same amount each time. You're adding the same amount each time. Well, we have moved up in the world now. Let me give you a different sequence. Obviously, this sequence is not arithmetic. We're not adding the same amount each time. What we are is multiplying by the same amount each time. To get from here to here, you multiply by 2. To get from here to here, you multiply by 2, and so forth. So guess what kind of function this is?
Exponentials?
Exponential, that's right. This is an example of exponential growth. So when we were talking about exponential functions, we had some number times some number to the x power. Well, it's the same thing here, except the letters are different. This is our first term, this is our second term, this is our third term, this is our fourth term, this is our fifth term. I want a formula for the nth term. And we've already figured out that I'm multiplying by 2 each time. So the easy part is to say 2 to the x. What we don't know is the y-intercept, the number out in front. Okay? Now let me show you a sneaky way to do this. If we graphed these points, The 3 would be the y-coordinate if the x-coordinate was 1. 1, comma 3 is that point right there. The 6 would be the y-coordinate if the x-coordinate was 2. So 2, comma 6 is my second point. And the third one is twice as big as that, and the fourth one is twice as big as that, and so forth. And we've got our example of exponential growth. But isn't this number the y-intercept? So isn't the y-intercept the number that would be in front of that one? If you had a term in front of this one, that would be your y-intercept. We could call it the 0th term because it's where the function crosses the y-axis, where the x-coordinate is 0. So all you got to do is go backwards. From 48 to 24, you divide by 2. From 24 to 12, you divide by 2. From 12 to 6, you divide by 2. From 6 to 3, you divide by 2. So to get this number, take the previous number and divide by 2. So that will be the number in front, because that's the y-intercept. There's the formula for this sequence. Now let's make sure. Let's let n, n, right, the nth term. Let's let n be 3. If n is 3, we should get an answer of 12. Well, what is 2 to the 3? Jackson?
8.
Now multiply 8 times 3 halves.
12.
You get 12. Because 2 goes into 8 4 times, and 3 times 4 is 12. So when n is 3, our answer is 12. Okay? So that's a sneaky way to do it. Just think about going backwards and think about having a term that's in front of the first term, and that'll be your y-intercept. Okay? Now I can ask you a question again, like, what is the 20th term? And if I ask you what is the 20th term, you would say, well, it's 3 halves times 2 to the 20th power. Now that looks pretty innocent, but it's a huge number. Let me show you on the calculator. I'm going to take 3 halves times 2 to the 20th power, and it's 1,572,864. We've gone up to the 5th term here, but if we go all the way up to the 20th term, we're over 1 million. That just gives you an idea about exponential growth. They grow very, very quickly. By just multiplying by 2 20 times, we're over 1 million, okay? So that's a neat way to figure out the number out in front, the y-intercept. Let's make sure everybody's got the point here, because I did a lot of talking and scribbling up here. Let me make up an geometric sequence. Did I say that? These sequences are not called arithmetic, they're called geometric. Arithmetic means you're always adding the same amount. Geometric means you're always multiplying by the same amount each time. And they exhibit exponential growth. So let's say that we start with 5, and then we have 15, and then we have 45, and then we have 135, and so forth and so on. So there's an example of a geometric sequence. And we're obviously multiplying each time by, Jackson?
3.
3, okay? So I know that my nth term will be some number times 3 to the nth power. And all we got to do is figure out the number out in front, and we'll be ready to go. Isaac, you got an idea?
So we divide the first number we have by 3. We get 5/3.
5/3 would be like the 0th term. This was the first term, the second term, the third term, the fourth term. So the one in front of it is the 0th term, and that's our y-intercept, and that's what we always put out in front. So that's right, 5/3, and there's our formula, okay? So now again, if I asked you what is the 10th term in this sequence, you could just put a 10 in there for n, and we've got 5/3 times 3 to the 10th power. You don't need to have the parentheses. 98,415. And that's only the 10th term. This other one, that one that was over 1 million, was the 20th term. But this time we're multiplying by 3 each time, so it's growing even faster. Okay?